Module 30 went more in depth on fiscal policy, so 31 will take monetary policy a little bit further. A lot of 31 will start out as review. We're going to see how monetary policy works. We will connect it to other models to see how expansionary and contractionary monetary policy will affect other economic models. We'll talk about how the Federal Reserve uses monetary policy to do something called inflation targeting to select what rate of inflation they find to be healthy for the economy. And then we'll look at an equation that tries to predict the Federal Reserve's behavior called the Taylor rule. So to review, the Federal Reserve is in charge of monetary policy, and specifically, they're going to be controlling the shifting of the money supply curve. The model that shows monetary policy has two names. It can be called liquidity preference, which is all about, do people choose to have cash in their wallets, or would they rather have that cash in the bank? It's also called the money market model. Now, the key idea with all of the monetary policy is that it only has short-run effects. So we saw at the end of the previous unit that short-run shifts will change the interest rate. We can see here that we have expansionary monetary policy. It's shifting right, and we have a decrease in the nominal interest rate. But in the long run, there will be a second shift that will undo the effects on the interest rate. It will return to the original amount. Because remember, money is neutral in the long run. It has no effect on the interest rate in the long run. So the Federal Reserve is using this for short-term problems, gaps like recessionary and inflationary gaps. Let's review how the Federal Reserve works. If their goal is to increase the money supply, of the three things the Federal Reserve can do, they control reserve requirements, the discount rate, and open market operations. If you remember, open market operations are the most frequently used tool within monetary policy. So we're going to see what they would do with these OMOs. And remember, OMOs are buying and selling treasury bills or treasury bonds. And I use this picture below because another word are government securities. So all of those things are the same thing. And the Federal Reserve is buying and selling these things between themselves, the Fed, and commercial banks. Remember, they pay them with excess reserves. So if the goal is to increase the money supply, would they buy or sell treasury bonds? They're going to buy them. The rule of thumb is buying equals making. So if the goal is to increase, they want to buy these bonds. When they buy the bonds, they give excess reserves to those commercial banks as payment. The commercial banks can use those excess reserves to issue more loans, and that increases money supply. And the next question is, if money supply increases, what's going to happen to these short-term interest rates? Remember, nominal interest rates are short-term because we spend cash so quickly that we don't have to worry about adjusting for inflation. So when we increase money supply, these short-run or nominal interest rates will fall. If you can picture the model very briefly, when you are increasing interest rates, that's going to be, increasing the money supply, that would make MS shift to the right, and it makes the interest rates fall. There's an inverse relationship between money supply and these short-term or nominal interest rates. Let's practice the other way around. If the Federal Reserve wanted to decrease the money supply, they're still going to use open market operations with treasury bonds, but if they're going to decrease the money supply, they will sell treasury bonds. Remember, selling equals smalling. When they sell these things to the banks, the commercial banks will pay them with their excess reserves. When banks have fewer excess reserves, that decreases the amount of loans they can issue, which decreases the money supply. We learned before that the money supply has an inverse relationship to short-term interest rates. So when money supply decreases, these nominal interest rates will increase. When the Federal Reserve is conducting monetary policy, they're doing this because they're trying to impact the federal funds rate. The federal funds rate is the lowest interest rate in our economy. It is the short-term loans that banks issue other banks if one of them is short on excess reserves. So the Federal Reserve can't directly control this number because it's what banks charge other banks, but they can influence this number because the money supply will impact the amount of excess reserves that banks have to loan out. So if the current federal funds rate is higher than the Federal Reserve's target for that number, they can increase the money supply, and that will decrease that rate. And just to remind you, the nominal interest rate, which is on the money market model, is the same percent as the federal funds rate. So when money supply increases and nominal interest rates fall, that also means that the federal funds rate is falling alongside. If the current federal funds rate is lower than the Federal Reserve would like, they can decrease the money supply. That will cause both the nominal interest rate and the federal funds rate to rise, and they can adjust this number until they get it very close to the target federal funds rate that they're after. Monetary policy shifts MS. It does not shift AD. Fiscal policy shifts AD. So once we keep it straight that those are different policies that shift different lines on different curves, there is truth to the fact that when you change monetary policy, it will set into effect a domino effect, meaning that whatever happens to monetary policy will start a chain of events that can lead to aggregate demand shifting. So when this happens, we're going to talk about expansionary and contractionary monetary policy. Remember, expansionary monetary policy means that MS is shifting to the right, and contractionary monetary policy means MS is shifting to the left. Investment spending by firms and businesses, is very sensitive to the interest rate. We call these things interest-sensitive expenditures, meaning that there's quite a few types of things that businesses buy that they know they're going to have to either take out a loan for or put it on their credit card. So when interest rates fall, those things become more affordable, and so we will see an increase in investment spending at that time. Consumption spending is another way to word consumer spending. This is spending by households. And there's quite a few things that households buy that they need to finance as well. So oftentimes households will take out a loan for a new car or truck. They take out loans for college education, or they take out home loans when they're buying a new house. So all of those things, if they're paying interest, those are also interest-sensitive expenditures. And when the interest rates are going up, you'll see a decrease in those types of spending. Some people will buy them either way, but others will wait until interest rates change to buy those things. Consumption spending and investment spending are both part of GDP, and they shift aggregate demand. So monetary policy changes the interest rates, but when interest rates fall, it changes two types of spending that shift AD, and that's the connection between monetary policy and aggregate demand. So when the interest rate falls, AD will rise. There's always a relationship where whichever direction MS is going, AD will eventually go the same direction. Let's go through the step-by-step process of how monetary policy will be used to affect ADAS. The whole purpose of connecting the money market model to the ADAS model is to show how monetary policy can be used to solve recessionary or inflationary gaps. So first of all, we're trying to figure out what kind of a gap that we're in. The ADAS model shows us gaps, so looking at the picture below, what type of gap is that? That's a recessionary gap. You can tell because equilibrium is to the left or less than our potential. Our potential is YP, that potential output. So if we're in a recession, we're trying to figure out what the Federal Reserve would do to the money supply. We've learned that whatever direction MS shifts, AD will shift the same way. So we can look at the picture with the gap and see, well, what needs to happen to AD? It needs to shift right. So let's start there. So if we're going to have MS shift to the right, labeling all the pieces, we're going to have MS2 with an arrow. You're going to have an E2, an M2, and an I2. So for our questions, what does the Fed do to the money supply? If they did a right shift, that is an increase. And our drawing, what happened to the interest rate, in this case, the nominal interest rate? It decreased. If nominal interest rates are down, what would happen to investment and consumption spending? They're both going to increase because if they're paying less in interest, their desire to buy those things will increase. If investment and consumer spending go up, AD will shift to the right. AD2, E2. I'm not sure if it'll show up there, but we want YE2 to be below YP because they're now lining up. And then PE2. So that's just practicing the shifting in the labels. Then we have a few more questions to see what actually happened to the economy at large. So shifting from E1 to E2, fixing our gap, what happened to real GDP? Real GDP is at the bottom here, and it went to the right, so it increased. How about our unemployment rate? Unemployment at E1, we had a recessionary gap. And if we have that recessionary gap, we're producing less than our potential, which means that our unemployment rate was very high. When you shift from E1 to E2, the unemployment rate is actually falling to the natural rate of unemployment. Now remember, the natural rate of unemployment is somewhere between 4 and 6%, and that's implying that we have frictional and structural unemployment, but the unemployment rate has gotten better than how it was during that recessionary gap. And then finally, the shift, what did it do to APL? The aggregate price level increased. If you need some more time to label your drawings, go ahead and pause it here. The previous chain of events was expansionary monetary policy because MS was shifting to the right. It was increasing. So let's see what we do now when we have a different type of problem. So looking at your bottom model, what type of gap are we in currently? That's an inflationary gap because E1 is to the right of our potential. So looking at the picture, what would you need to do to AD to get out of that gap? If AD decreases or shifts left, it will fix the gap. So if AD is going that way, we need MS to go that way too. So what is the Fed going to do to the money supply? They're going to decrease it or shift it left. That makes this one contractionary monetary policy. So we're drawing this on the model. We have MS shifting to the left. So we have an MS2, an E2, M2 for the quantity of money, and then I2 for the effect on the nominal interest rate. So after that shift, what happened to the interest rate? It increased in our drawing. If nominal interest rates are high, investment and consumption spending will decrease. It will cost them more to finance those projects, so they'll probably wait until the rate of return of more of those things is worthwhile. So if investment and consumption spending decrease, AD will shift left. it will decrease as well. That gives us an 82. E2, YE2. And remember, we are not shifting YP because YP is connected to LRAS. And if LRAS didn't shift, YP didn't either. And then PE2 here. All right, so now that that's fully labeled, let's answer the rest of our questions. That shift made real GDP decrease. When you cut the money supply in contractionary monetary policy, it will affect the total number of purchases that are being made, and it will affect our output. Remember, real GDP shows us aggregate output in the economy. So even though we're fixing inflation, we are reducing our overall output to do so. Now, unemployment rate. E1 was actually, because it's to the right of potential, that means that we had very low unemployment in the inflationary time, usually unsustainably low. Inflation and unemployment are trade-offs. So when inflation is high, unemployment is so low that when you try to fix inflation, what you end up doing is raising the unemployment rate. Now, it's going to go back to that same natural rate of unemployment, meaning that maybe it was at 3% unemployment during the time of inflation, and now it's gone back up to somewhere in the 4 to 6% zone. So even though it's considered full employment, it increased to get to that point. And then because we're fixing inflation, the aggregate price level decreased. Yet again, if you need more time to label your models, go ahead and pause here. Here we have the rule we keep discussing. Increasing the money supply leads to an increase in AD. They always move in the same direction. So this means that expansionary monetary policy will lead to a right shift of AD. It does not mean that we're going to have expansionary monetary leading to expansionary fiscal. Even though fiscal policy shifts AD, the reason AD shifted had nothing to do with government spending, taxes, or government transfers. AD increased because of consumer spending and investment spending. So they go in the same direction, but there is a difference between monetary and fiscal policy. And the Federal Reserve doing something doesn't make the government do something within fiscal as a result. It's also important to note that the order matters. Money supply leads to AD. More money leads to more spending. The rule does not work in the opposite direction. What happens to AD does not mean that money supply will change the same way. Just because people are buying more stuff in AD doesn't mean that the Federal Reserve will all of a sudden decide to print more money. So the rule is true exactly as it's stated. Increasing money supply leads to an increase in AD. So far, the reasons that we've discussed that the Federal Reserve would use monetary policy would be to get us out of these recessionary and inflationary gaps, usually implying that the whole point was to have them help if we have too high unemployment. But the Federal Reserve also is concerned with price stability. So if inflation is too high in an inflationary gap, the Federal Reserve would also want to get involved, potentially, in that situation. The problem, though, is that you can't solve both of those issues at the same time. If you're fighting a recession and trying to reduce unemployment, the end result is prices go up. Fighting unemployment causes inflation. If you're trying to reduce an inflationary gap, when you take money out of circulation, that means fewer goods and services are purchased, which can lead to companies laying off their workers. So when inflation goes down, unemployment goes up. So for this reason, the Federal Reserve sometimes has conflicting goals. If they try to solve one, they're making the other worse. And that's why we have kind of zones of acceptable percentages for both the inflation rate and the unemployment rate. So they're both going to fluctuate, but the goal is to keep both of them in these healthy ranges that are maintainable in the economy, because neither one of them is going to be zero and perfectly eliminated, because that would make the other one quite high. Because of the conflicting goals of trying to fight inflation and fight unemployment at the same time, it's hard to predict exactly what the Federal Reserve will do. Are they going to raise rates or lower rates? Which problem are they trying to solve right now? And economists didn't like the unknown nature of this and not being able to predict what was happening next. So, John Taylor is an economist at Stanford University, and he came up with an equation called the Taylor Rule. And this predicts Federal Reserve behavior. So, this equation is used to decide what the target federal funds rate should be. So, basically, are they doing with interest rates by looking at both the current inflation rate and the output gap. Inflation rate clearly tells us how we're doing with inflation right now. The output gap shows us the current unemployment numbers. So looking at where those numbers are now, we can use this equation to figure out a guess of what the Federal Reserve might do. Since the Taylor Rule is looking at the inflation rate and the output gap, I wanted us to review what the output gap is, how we measure it, and where we find it on these models. Output gap is the gap between our real GDP, our current output, and our potential output. So on the ADAS model, just to remind you how we would label all these things, our current output is YE, and our potential output is YP. We've been labeling these things right for months now, but we're going to use these two things and measure them. We will subtract the difference. If the real GDP is bigger than our potential, we have a positive gap. So you can see in this case, our real GDP, our output, is smaller, it's to the left, it's less than our potential. So our output gap is negative. And that tells us not only that we're in a recession, but you can actually measure this in dollar amounts and see if we should be making $800 billion worth of products in our overall economy, and we're currently making $600 billion, we can see the size of the recession. And of course, economists want to figure out, is it a really bad recession? Is it a really bad inflationary period? Because if it's really bad, they might be more inclined to act than if we're just slightly away from our potential. So here we have our Taylor Rule equation with a nice picture of John Taylor to go with it. So the Taylor Rule states the federal funds rate, or the target federal funds rate, equals 1 plus 1.5 times the current inflation rate plus 0.5 times the output gap. Now looking at this equation and knowing that both price stability and low unemployment are goals of the Federal Reserve, which looks like a higher priority? Which one are they literally weighing higher according to this equation? The inflation rate. You can see that it's multiplied by 1.5, whereas the output only multiplied by 0.5. So future Federal Reserves might prioritize these two things differently, but the Taylor Rule has actually been quite accurate in measuring what the Federal Reserve has done over the past few years. And we'll look at a chart to see how what the Taylor Rule has predicted would happen would compare to what has actually happened. This table is showing the actual federal funds rate compared to the predicted federal funds rate according to the Taylor Rule from 1985 to about 2010. Now you can see that these are not identical. The Taylor Rule isn't perfect in terms of the exact percentage point, but you also can see that when the federal funds rate is rising, the Taylor Rule is rising with it. And when one of them falls, the other one falls too. So in terms of just generally predicting when rates will rise and fall, it's been fairly accurate so far. There's no perfect way of knowing what's going to happen, but a lot of times economists like looking at this as a way to help them explain what might occur next. Inflation targeting is the concept of the central bank of a nation having a zone for what they would like the inflation rate to be, and sometimes deciding to act if the inflation rate gets outside of that target range. Now, of course, other nations have central banks that are not the Federal Reserve. That's just the name of the American central bank. And each country also has different ranges for what is a normal inflation rate in their nation. America, the inflation rate that we consider to be healthy, is usually between 1 to 3%. So other nations have other percentages that are healthy for them. Because of the Federal Reserve's policies, they seem to keep the inflation rate around 2%. There have been exceptions to this rule. During the Great Recession, interest rates were kept extremely low for many years. So even though the normal is 1 to 3, interest rates were actually below 1% for a number of years. The very, very lowest interest rates, the federal funds rate, would have been below that healthy amount. So you can see how even though this target may be true, the target itself fluctuates, and whoever the Fed chair is could also impact how closely they want to keep to this number.